All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue doing Rust research. I'm not sure which subject I should say we are focusing on because yesterday we were supposed to be continuing our Rust Tokio studies, but then that turned into doing a bunch of web development research that's focused on Rust, or rather, I should say, research on doing web development with Rust and WASM, or well, more specifically Rust, because it gets compiled to WASM, at least for the more dynamic portions. But yeah, mainly web development with Rust. That's what yesterday turned into. Also, um, I was pleasantly surprised to notice the time today. I managed to start the stream on time. Well, I wouldn't say on time, but like a little earlier. I managed to start the stream a little earlier than what what I've usually been doing for these past couple of days. And because of that, I think we'll be able to stream for maybe 2.5 hours today. Yeah. Hopefully 2.5 hours. Give me a second. Yeah. Okay. So, um, to start off the stream, I'm currently doing some research on. Well, I don't know if. Yeah. But I don't know if I would call it research. What is Dim Forge? Let's open this up as well. But yeah, I don't know if I would call it research, but like I was suddenly interested in checking if Rapier, the physics engine built in Rust, if it supports vehicle physics, specifically vehicle physics. And yeah, that's why I'm opening this. This is an engine that I'm gonna be looking into later on once we get into like the game development side of things, and maybe also once I start creating a separate VTubing setup using Rust and Nano and stuff. Maybe I might use some physics stuff from this crate. That should be interesting. Um, but yeah, I was checking out the wait. Okay, what is this? Creators of Dimensions, open source Rust libraries for scientific computing. N algebra, Simba, um, Parry, collision detection, efficient 2D and 3D geometry library, geometry library, interference tests. Okay, contact points computation. Okay, fluid simulation. Okay, and Rapier is part of that. I'm interested, very much interested in the fluid simulation thing. Um, and I didn't realize that I would need a separate library for collision detection. I figured Rapier did that by itself. Like I figured Rapier included. Oh, I think this might be the important part. No STD. So this doesn't rely, or maybe it has a version that doesn't rely on the standard library. That might be one of the differences. Okay, all right. So I'm guessing yeah, Rapier probably also includes because when something says physics simulation, then I assume that physics simulation also includes collision detection. And I'm pretty sure it does because if you look at the demo, which by the way, yeah, I was looking at the demos for Rapier to see if there's any um, if I can find any vehicle physics related stuff. I don't know how good or bad the framework is on stream. Oh god, the framework is awful. I think it's this website that's taking up frames. Um, it's fine. I can close it later on. Yeah, I just need to look at all the different demos that they have. Oh God. Okay. All right. Um, then we have joints. I'm not sure if this is supposed to be moving. Yeah, I'm not sure. Okay, then what is this? So another thing is with these demos, I'm not sure if there's any controls that I'm not aware of. So I need to explore this later on. Um, locked rotations. Oh, okay, okay. Rotations locked to a specific axis. Okay. And then polyline. So far we're looking at 2D. Um, we're going to look at the 3D demos that they have as well. Give me a second. Let me just open up my stream on my phone so I can look at the chat. Also, um, we can probably close this so I can open up the 3D thing. I don't think I looked at cubes, did I? Oh yeah, I think I did. Yeah, I looked at cubes. There was another thing. This was interesting as well. Convex polygons. This is for more like complex shapes. So it's not like primitive shapes like, you know, circle and rectangle and stuff. It's you can create like complex shapes. And this, I looked into this earlier. It just occurred to me what they meant by collider groups here. You're basically defining, you're essentially creating like collision masks. So you can decide which specific surfaces a body can collide with or a collider can collide with. Okay, now just a second. Let me open up my stream. Okay, all right. So now, just a second. I'm gonna transition back. Well, I'm gonna go to BRB is what I meant. So I'll open up Rapier and then actually I should also see if there's any unloading that I can do that could possibly help speed things up a little bit. Right, so we have this GitHub page open. We have, I think, the Redis page open. We can close both of these. We have the Google search open. We can close that. We have itch. We can close that. I've been enjoying stuff on itch, dude. I love how seamless the integration is. Or, I mean, I was surprised to see how seamless the integration was. Not even integration, how seamless the support was for the Xbox receiver that I have, the Xbox controller receiver. I just had to plug it in and the thing was working. I was worried that I would need to go and download like drivers or something, but no, it just worked out of the box. Bonus, it even works with an extension, which I've had issues with on other machines. but like it seems to work with a USB extension on this machine. And so I'm able to play browser games on my Linux machine now. So far, I haven't continued playing on on this machine where I'm streaming from right now. I haven't continued playing on here because the what do you call it? Because of that um, the whole controller issue where I needed to, restart the system. So far, I haven't restarted the system because everything seems to be going well with the system, and I don't want to restart because like things are running smoothly right now. So just for the sake of gaming, I don't want to have to restart. I'm gonna run this as long as it runs, and the next time that it freezes, then I'm obviously gonna be restarting it. So at that point, I can, you know. Okay, right. So I have opened up the the next thing. So these are the 3D examples. I'm also curious about how the rendering is being done here. They do have the examples available online, but I don't know how the rendering is being done here. I was assuming they might be using some other library for it. These are like simple shapes. It's not something complex that's being rendered, to be fair. But um, yeah, I don't know if I mean, okay, if Rapier by itself provides these very simple shapes, that does actually help a lot because it'll help people do their prototyping quickly using Rapier's own uh, whatever rendering tools they provide. Oh, also, yeah, that fluid simulation thing. I need to look into that. Hold on, I'm interested in that now. Wait, okay, we need to close this, so we will keep that in mind. Let's switch. Okay, this is our character. Oh God, what just happened? That is not what was supposed to. What just happened? Okay, it is cycling through. It is cycling through these examples. Okay. Yeah, dude, I'm glad that we have this kind of thing going on. I'm curious about how they have set this whole thing up. Does Rapier itself have some tools available to let you do this? I mean, again, they're simple shapes, but being able to use these simple shapes to set up your 3D world or your 3D simulation, it does help. Like not having to use, not having to import a whole external library, and instead having these very primitive shapes that you can build simulations off of, it helps. And this is also reminding me of how I wanted to get into doing like robotics stuff. And I was finding, how do I say this? I wanted to get into doing robotic stuff. Robotic stuff involves, of course, deep learning, but more specifically, reinforcement learning. And for reinforcement learning, you had a bunch of different like tools available. A lot of them were like suites of their own, and many of them like they had their own set of tools. Sometimes all packaged into one tool itself, with integrations for other extra tools if you need. But I want to see if I could maybe set up simulations by myself without using those tools. So once I understand exactly what I'm trying to do, because I never got a chance to go too deep into reinforcement learning. At some point, we're going to do that. But what was I saying? Yeah, I want to. Okay, so when I was doing research on reinforcement learning, I'd found out that there's this thing where you're able to spawn a world, and your agent, your model that you're trying to teach, it's operated by an agent. So like the concept of an agent is already in that world, like it's already set up in that world, and you have this agent. The agent has to accomplish a goal, and you give it rewards or something negative, some kind of punishment if it does wrong. You give it a reward if it does good, and you give it something negative if it does wrong. So through this positive and negative reinforcement, it learns what it's supposed to do. Um, the interesting thing was there was an entire like simulation that would be running there, and your agent would be running within that simulation, right? And that simulation was very tightly coupled with the 3D representation of it, or if you were setting up a 2D thing, then 2D representation, but it was very tightly coupled with the 3D representation of that world. So what I want to see is if I'm able to set up pretty much a similar simulation to that, but if I can set it up by myself um, within this within the Rust ecosystem. I don't know if I explained that very well. What I'm trying to do, what I'm trying to say is that what I am trying to do is set up the entire reinforcement learning workflow in Rust using all the various tools provided with Rust. I'm very curious about the rendering thing in in Rapier. Maybe I could create a new conversation and ask the question there. Hold on. Just a second. Let me. I guess I can do it here. I can open up an instance of which one is it? I was having a bunch of web development related conversations yesterday with Gemini, even after ending the stream. I continued with the research. Um, and I got to learn quite a bit, dude. In terms of web development, I'm definitely going to be going with Rust. I'm going to be moving forward with Rust. And I realized through the research that I need to learn both Zola, which is a static site generator library, and Dioxys, which is, let's just say, a web development framework in Rust. I need to learn both of these because they both accomplish two different things. Dioxys would be great, especially for single page applications. You can do multi-page applications with it as well. That gives it like a more dynamic kind of thing, and it has, at least from what Gemini told me, it has ways of simulating um, that thing where you click on a link for a page. Like let's say you're on the home page, and this is all like within that same application. You start out in the home page, and then you click on the about page, and so it's supposed to load the about page, right? Generally, that's how it would work with a static website. It unloads that home page and it loads the about page, and of course you're going to see stuff changing as well. Obviously the page loads, but also the address bar changes to that specific address. In this case, apparently the framework is able to simulate, or whatever system is running all of this is able to simulate that kind of behavior. So you'll still get a similar kind of behavior, but it's all running off of your web application. But the important thing is that it's a dynamic thing. It's a web application. None of that content is static. None of that content is part of the HTML. Whereas if I, you know, went the static site generation route, there would be a bunch of content within like pages. So I need to pick and choose which tool is necessary, which tool is right for the job. So a single page application, I would use it for specific purposes, but other than that, I think I'm just going to stick with the uh, the static site generator. But that's kind of why I want to learn both Zola and Dioxys, because they can both be helpful in their own ways for different purposes. But Zola is definitely going to be a lot better for creating static sites and SEO friendly sites. What was I going to do? Oh yeah, um, yeah. So I was gonna ask a question here. I'm doing some research on the Rapier um, framework in Rust. Looking at their website, no, oh, there are demos to, well, demonstrate various concepts that the library supports. I noticed that there are graphics, albeit simple, primitive shapes, but there are shapes being displayed. What I'm wondering is, does Rapier have some basic um, graphics rendering tools, or am I going to need to use an external crate for that? An external crate, let's say like Nannou, Bevy, etc. for that. Okay, now while this answer is being created, holy shit, dude, things are slowing down big time. Give me a second. I need to open up my. I think it might just be the fact that my browser hasn't been. Well, that shouldn't be an issue because ever since I started doing the about processes thing, like because Firefox does have a thing where you can see a sort of task manager but specifically for Firefox. And that has helped me a lot, especially in my other more resource constrained systems. I'm able to close a bunch of tabs that are not currently being used a whole lot. All right, just a second. Um, I'm waiting for the task manager to load up and show me the numbers because everything is going so damn slow. Oh, wait, did we not? Oh, I forgot to switch back from okay, just a minute. Right. So Firefox seems to be taking up a bunch of the GPU, the GPU time. Fortunately, OBS is also taking it up. Um, the terminal is also taking it up, and my VTuber app is also taking it up. But I think I can, yeah, I think it might be the rendering for this environment here. That's really causing the issue. That's okay. Right, we can take a look at the next example. Dude, I love that these controls are there. I'm super curious about whether these things are being done like this, these control, because it says JS demo. So I don't know if this functionality was brought in through JS, and it's like what do you call it? Rapier is being compiled to WASM and then loaded up in JS so that this stuff can be done, or if Rapier itself does support very basic rendering, which it's not really a problem. Even if it doesn't support very basic rendering, I could probably use something else. I'm gonna be getting into Nano anyways, but it would be good if we had the option even for very basic stuff. This says CCD. What is this? What is this called? Let me just Google physics simulation CCD. What is physics CCD? CCD stands for continuous collision detection. Okay, okay. If enabled, it'll be used for that particular actor. It can be have actor, dude. Okay, I just remembered. Yeah. So Tokio, we were learning Tokio, right? The reason we got into Tokio is because, among other things, among other frameworks, the Ractor framework, which is an actor framework, that framework uses Tokio internally, like in the back end. We need to get into Ractor as well because Ractor has interesting functionality that I feel like I can use in some of my other applications. But yeah, okay. Next, damping. Okay. Oh, the example here was dampening over time. So yeah, okay. So the velocity gets dampened, the rotation, the torque gets dampened, all of that. Okay, all right. Then fountain. That's interesting. Give me a second. Okay, then we have the height field thing. I haven't understood what this is doing exactly, aside from like collision detection. Yeah, there might be some kind of concept that I'm missing that this thing is demonstrating. Okay, then we have joints. Nice. Nice. All right. Then we have this Kova Tower. Oh God, it is so slow. It is definitely this thing. This is definitely what's taking up a bunch of like the GPU time. Locked rotations. Okay. Then platform. Oh, is this simulating the platform itself moving? Yeah, I think so. This is simulating the platform itself moving. Okay, then pyramid, and finally triangle mesh. Okay, so we can close this, and I'm curious about this fluid simulation thing. Is there like a home page? Good, they have 2D and 3D. Allows optional interfacing with rigid body physics engines. This is interactive or offline fluid simulation engine for both 2D and 3D applications. All right, let's open this up. Um, First things first. All right. Multi-phase fluids, two-way coupling with Rapier, two-way coupling with rigid bodies, multi-bodies, and deformable bodies from the Rapier physics engine. Forever free and open source. Hell yeah. Awesome. Multiple models to choose from. Choose different mathematical for pressure, resolution, viscosity, etc. To achieve the best compromises for your simulation. Do they have like a demo thing somewhere here? I don't think they've set up a demo thing for this. But I do want to look into this because it seems interesting. Okay, I think now our frames are good because um yeah, yeah. Now now the frames are much better. Okay, Salva is a two and three-dimensional particle-based fluid simulation engine for games and animations. It uses N algebra for vector matrix math and can optionally interface with N physics for two-way coupling, with rigid bodies, multi-bodies, and deformable bodies. N physics, wasn't this the one that was deprecated? N collide, N physics, deprecated libraries. So I'm guessing, yeah, now it's Rapier instead. Examples are available in the examples 2D and 3D directory. Okay. Um, because those demos are based on WASM and WebGL 1.0, they should work on most modern browsers. Feel free to ask for help in the user. Where are those examples though? Like, are they hosted on the website or something? Okay, let's try opening up docs. Okay. Let's try opening up the GitHub repo and see if there's any way that we could see examples. And in the meantime, just a second. Just a second. I'm just checking something here. Okay, somebody did ask the question recently whether it works with the latest Rapier. Um, and there doesn't seem to be a response. Okay, I guess I can test this out when I need it, like when I actually need to, get into this. but for now, I don't think I need to. Oh, okay, it's a tutorial. Yeah, I think we can close this. We can close this for now. I haven't even gotten to Rapier itself, so no point in diving too deep into it. It was fun to do the research though, because um I feel like I might be able to use this for. Actually, no, there was another thing. Dude, I need to look into reinforcement, like pure Rust based reinforcement learning libraries, because it's a little more than um just setting up the simulation world. I'm now remembering that there was, okay, so there was this tool that I had seen. It was a suite of tools, but like there was a editor. Within that editor, you could like design your entire world. They would give you access to a bunch of components and stuff that you could use to, let's say, if you were trying to build a robot arm, right? They would give you the tools to sort of build a simulation of that arm in the 3D world, and each of the components that are provided, like electronic circuitry related components, stuff like a servo motor, um, simple stuff like LEDs or any other components and stuff. They give you each of these components, and those components are like programmed to behave how they would in the real world. So they're meant to simulate that entire thing, and then from that simulation, your model is supposed to learn so that it can eventually apply that knowledge to a real world scenario. I'm curious about this now. Hold on. Actually, okay, I can probably ask the question to Gemini itself. Okay. You are correct. Rapier itself does not handle graphics rendering. It's a physics engine, not a game engine. Its sole focus is so and so for visual for the visual representation. Holy shit. For the visual representation, you will need to use a separate graphics crate. The simple primitive shapes you see in the demos are rendered using an external library that works in conjunction with Rapier. Popular choices um, in the Rust ecosystem for this include Bevy, Kiss 3D. I haven't touched Kiss. I did look into Kiss. I don't remember if it's still actively in development. The whole idea with that library was that things were supposed to be simple. Kiss, I believe um, it's called Kiss because of Keep It Simple, Stupid. Um, I don't remember if the library is still actively in development. Wait, I could probably look it up on this machine right now, because there isn't too much of a load. I just now I'm realizing how much of a load that website was putting. Okay, Kiss 3D. By the way, speaking of Kiss, dude, if you guys haven't watched this series on Netflix called Kiss Me First, holy shit, you guys need to check it out. Man, what a series. It is crazy. It kind of I don't even know where to start with it. Like it's about these people that meet up in the virtual world through, like, their version of VR. They become friends in the virtual world, and then like slowly, actually it's not they become friends, it's like one person joins another group of people, like she stumbles across that group of people in the virtual world, and then she slowly starts hanging out with them more and more, and then things start to happen IRL, and this person, she notices things that seem shady, and slowly it kind of like, the virtual world and the real world, they kind of like I don't want to say blend together, but like she realizes that stuff that's happening in the virtual world is having a direct effect on the real world, and so slowly things bleed over from the virtual world to the real world, and that's the best way that I can explain it. Like, go watch the series. It's pretty awesome. It's on Netflix. Okay, so this is KISS 3D. Keep it simple, stupid 3D graphics engine. 3D, I just remembered that. Did I say earlier that it was in 2D? I don't remember. Okay. Keep it simple, stupid 3D graphics engine. This library is born from the frustration that today's 3D graphics libraries are either too low level, you have to write your own shaders, and opening a window takes 8 hours, 300 lines of code. Yeah, okay. Um, and 10 liters of coffee. Or too high level, but too, no, or high level, but too hard to understand and use. These libraries are made to create beautiful photoreal or close to it animations or games. They have many features, too many in fact, if you just want to draw a few objects on the screen with as little friction as possible. KISS 3D is not designed to be feature complete or fast. It's designed to let you draw simple geometric figures and play with them with as little friction as possible. Features: WASM compatible, out of the box, open a window with a default arc ball camera and a point light. Okay. Um, First person camera available as well, and user defined cameras are possible. Render boxes, spheres, cones, cylinders, quads, and lines simply. Change an object's color or texture. Change an object's transform. We use an algebra to do that. Create basic post processing effects. Do they have, so they mentioned WASM, right? So do they have like some kind of demo that we can look at? This project is sponsored by DemForge. Hell yeah. Hell yeah. Okay, is there, yeah, I'm not seeing, they probably have an example section here, but I don't know if there's a link to, wait, did I not click that? Okay, I did. Yeah, I might need to compile and run these examples myself. Yeah. Do they have like maybe some screenshots or something? No, hold on. Is there really no like website that we can look at? Let me look this up. Kiss 3D. Okay, there's a Rust thing. Okay, okay. Okay, you know what? I'm gonna ask I'm gonna ask Gemini. Also, there was I was gonna ask a question here. What was the question I was gonna ask? I forgot what the previous question was that I was gonna. Oh, yeah, okay. Um, I am interested in reinforcement learning, RL. I'm aware that there are a bunch of tools in the Python ecosystem to do that, but I'm wondering if there are any tools on the Rust side that would help me get started with RL. From what I understand, the general idea is that I would need to be able to simulate a world, um, and oh, I should mention this as well. I'm interested in reinforcement learning for robotics. and also simulate the hardware that I plan on using, and then also simulate, no, also set goals and limitations for the agent so that a model can be trained and then eventually applied to real hardware. What are my options here? I'm just doing research, so don't take any right actions. Just give me the info. Right now, there was another conversation that I was gonna have here. Oh, okay. Okay. Since you mentioned, oh, okay, this says that the official Rapier examples often use Bevy or KISS 3D to render the physics simulation. Okay, since you mentioned KISS 3D, I'm curious about something. I do plan on getting into Nano for creative coding, but out of the box, Nano is for 2D stuff. It does support 2D, does support 3D, but it's officially for 2D. So to do 3D stuff might require a bit of a setup. What I'm wondering is, should I, um, since I'm planning on learning, which, okay, look, to be fair, to a certain extent, I'm sure Nano would be able to handle 3D stuff. It's not officially for 3D, but like I'm sure it can handle 3D stuff to a certain extent. But I feel like um, Kiss would make it simpler to create a scene that has these that has, you know, a bunch of 3D shapes and stuff. At least from what I've seen in Nano, I would need to specify the shape itself. Like I would need to mathematically define the shape and then have that be rendered. What I'm wondering is, since I'm planning on learning Nano anyways, should I touch Kiss 3D for 3D stuff or try and accomplish the 3D stuff in Nano itself? Because from what I understand, the whole idea with Kiss 3D is to give you an extremely simple set of tools to help you accomplish um, very specific 3D rendering tasks. Okay. Was I asking a question elsewhere? Yeah, here. Okay, cool. So let's read this. Oh, damn. Lots of information here. Of course, you've got a good handle on the components needed for robotics IRL. While the Python ecosystem is dominant, the Rust ecosystem is growing, and offers compelling advantages, especially in performance and safety, which are critical for robotics. Here's a breakdown of your options in the Rust ecosystem for getting started with reinforcement learning in robotics. The Rust stack for robotics reinforcement learning. Instead of a single all-in-one framework, you would typically assemble a stack of high-performance libraries. Okay, physics simulation. You have Rapier and Bevy. Okay, all right. Then hardware and robotics simulation. The agent's body. Okay, this is interesting. So I haven't looked into any of these. This is a library for parsing URDF, Unified Robot Description Format files. Um, Used to describe all elements of a robot. This library is essential for loading pre-existing robot models. Okay, and algebra, OpenRR, a more comprehensive, less commonly used open source robotics research platform in Rust. It provides tools for kinematics, path planning, and more. It's a higher level framework if you need more than just the basics. Wait, what does NAlgebra support for robotics? You will use it constantly for calculations involving vectors, matrices, transformations, and quaternions, which are the language of robotics. Okay. Neural network, Burn, Torch, and then there's RL specific libraries. There isn't a dominant stable baseline equivalent yet. Stable baselines. Where have I heard that name? Hold on. Stable baselines. Give me a second. Let me look this up. Stable Baselines 3 is a set of reliable implementations of reinforcement learning algorithms in PyTorch. That's probably where I've heard it. Oh my god, why is this so slow, dude? Oh shit, it's because I have the simulation open. Yeah, that's my fault. Okay, my other machine is kind of stuck right now, so let's continue reading this. Oh, okay, now it's not stuck anymore. So we can close a bunch of these things that are very much eating up memory, and things should be much faster now. Just a second, there's a couple more things that I need to unload. Okay, in the meantime, we can read this. So, oh, let's go down here. You've captured the trade-off perfectly. Um, Both Kiss 3D and Nano are excellent choices, but they serve slightly different purposes. And the best one for you depends on your immediate goals. Use Kiss 3D if your goal is quick and simple 3D visualization. Kiss is fantastic for getting a 3D scene set up and running with minimal boilerplate. If you just want to throw some cubes, spheres, and lines on the screen and visualize a physics simulation like with Rapier or a simple algorithm, KISS 3D is hard to beat for the simplicity. Or if you want a just works experience, it comes with a built-in camera controller, lighting, and object manipulation that require very little setup. All right. You're not focused on the aesthetics. While you can do some customization, KISS 3D is not primarily designed for high fidelity graphics or complex visual art. It's a prototyping and debugging tool first and foremost. I feel like I need to remember that part. Right, then moving on to Nano. Uh, use Nano for 3D if your goal is creative coding in 3D. Actually, to a certain extent, it is, but like in this case, we are talking about reinforcement learning. Actually, not just reinforcement learning, even like just physics in general. But anyways, um, since you're already investing in the Nano ecosystem, learning its 3D capabilities will be a natural extension. Nano is built for creative expression, so its API, while more involved for 3D, is geared towards generative art, custom shaders, and more complex visual compositions. Or if you want more control and flexibility, Nano is built on web GPU, giving you much more power and control over the rendering pipeline. This is essential if you want to write your own shaders or create unique visual effects that go beyond simple shapes. Or if you want to unify your toolset, sticking with Nano for both 2D and 3D means you only have to manage one creative framework. The concepts you learn, like the Draw API, windowing, and app state management, will be transferable. While the 3D setup is an extra step, you won't be starting from scratch. That is true, actually. That is, yeah, yeah, that is true. I do plan on, yeah, I do plan on doing a bunch of stuff with Nano. So because I'm going to be using Nano anyways, then adding 3D into the mix is not going to be that much of a problem. But then if I try to use Nano for 2D and KISS for 3D, I'm just learning an extra framework for no reason. Well, I mean there is a reason, but like I'm learning an extra framework when I don't have to, is what I'm saying. Also, I'm wondering if I should just stick with what do you call it? With Python for reinforcement learning. Because I've done this in the past where where I did research on tools. I believe I did go into, and I think I had done that on stream, in fact. I think I'd done that on stream. The research that I was doing regarding it was on stream. Um, I did find that, there are Rust based tools, but um, the Python ecosystem is much more mature for fuck's sake, dude. Yeah, there you go. Okay. The the Python ecosystem is much more mature for this kind of stuff, for reinforcement learning, because a lot of the tools they've had time to mature, they've had time to become better and get more features added to them and just be overall much more polished. Um, so you know what I should look into? Once I do actually start using RL models and once I start building training and using RL models, I need to look into how well that transfers over to embedded stuff because I feel like the majority of the time I'm going to be using RL models for robotics stuff. Though, okay, hold on. Just a second here. Um, hey, since we are talking about robotics, I'm learning, I'm currently learning deep learning. This means I'm learning hold on, dude, this keyboard, I need my other keyboard so I can type properly, but then on the other keyboard, there might be some lag issues because of the other machine. Okay, this means I'm learning various NN architectures like FCNN, CNN, RNN, transformers, etc. So far, I've heard that RL is heavily used in robotics, but I'm wondering if any of the other architectures get used as well. The answer is yes, in different stages. They get used in different stages, like um, getting a robot to understand what it's looking at. You're probably going to be using a convolutional neural network or a transformers based neural network just so it can like understand the image, right? Just so it can process the image, because I'm not entirely sure reinforcement learning is the best tool for that purpose. Um, though, okay, all right, okay, hold on. But I'm wondering if any of the other architectures get used as well. Also, in terms of moving over these models to moving over these specifically RL models to embedded platforms, how does that whole thing work? Also, is RL through Onyx even a thing? Like, can I train uh, an RL model through PyTorch and then export export it and run it through, well, export it to Onyx and run it through an Onyx runtime? All right. What is? Oh, damn! Why is this so broken up? This output looks so broken up. What's going on here? Oh, okay. All right. Um. Oh, did I not ask a question here? I guess not. Okay. All right. Now let's wait for this response. And in the meantime, wasn't there something that I was gonna look at? I guess we are not doing Kiss 3D anymore. We're gonna stick with Nano since I plan on using Nano for so much more. Let's not add more and more libraries to the. Oh God, what did I just open? Was that the Strudel thing? I think that was the Strudel. The Strudel. What do you call it? The Strudel web page. Let me just unload that real quick. Okay, I think we should be good. Just a minute. I accidentally clicked something here and then, yeah. Okay. All right. So, um, where was I? Reading. Yes. So we're gonna go back up here No. Was it here that I was reading? No, it was here. Think so? Yeah. Okay, that's an ex that words. That's an excellent set of questions that gets right to the heart of applying modern ML in real-world robotics. Let's break it down. Are other NN architectures used in robotics? Yes, absolutely. In fact, reinforcement learning isn't an architecture itself, but rather a training paradigm. An RL agent is almost always built using one or more of the architectures you mentioned. Think of it this way. RL is the process of learning. I actually didn't realize that. I thought reinforcement learning had like a bunch of RL based architectures, and there would be neural networks being trained for that. I guess I was wrong about that. Think of it this way. RL is a process of learning from trial and error, while architectures like CNN and RNNs are the building blocks. Wait, so RL is a training method? RL is a training method. Okay. CNNs and RNNs are the building blocks that form the agent's brain, the policy and or value function. Here's how each architecture is commonly used in robotics. FCNN. Okay, okay, all right. Joint angles, velocities, distances from sensors. An FCNN is often used as the policy network in RL. It takes this vector as input and outputs another vector representing motor torques or target positions. The NN.linear layers in many of the snippets you provided are the building blocks of, okay, I never provided anything, but okay, are the building blocks of feed-forward neural networks. Okay, just a second. Okay. CNNs, the eyesight of the robot, the eyes of the robot, essentially for any task involving visual representation from cameras or spatial data from LiDAR, right? Okay. RNNs, the memory of the robot. RNNs are designed to process sequences of data that this is crucial when the robot needs to understand context or history. Okay. Transformers. Role, the context aware brain for complex multimodal tasks. I feel like I might be relying more on CNNs and RNNs, maybe. If transformers based networks end up being too heavy for embedded hardware, then I might need to rely on CNNs and RNNs. Okay, how do you move RL models to embedded platforms? This is the critical training versus inference distinction. The massive power-hungry computation happens during training. The final optimized model runs on the robot is built for efficient inference, just running a forward path. Okay, all right, yeah. This comes back to that thing that um, like where I realized that RL is more of a. I should hold on. I should confirm this. Is RL through Onyx a thing? Yes, absolutely. This is very common, and if this is a very common and effective workflow. To be precise, you don't do training through Onyx, you do inference. Um, Wait, so RL is more of a training method, or set of training method. It's not a bunch of NN architectures. Okay, while this responds, let me, okay, there's the there's a response. That's absolutely correct. You've hit on a fundamental distinction. Reinforcement learning is indeed a training paradigm or a set of methods for how an agent learns to make decisions. It's about learning through interaction with an environment, receiving rewards or penalties. That's a word that I wasn't able to remember. I kept thinking punishment. And figuring out a policy, a mapping from states to actions that maximizes cumulative reward. Neural networks are the function approximators or brains that an RL agent uses. When we talk about an RL agent, its policy and often its value function is typically implemented as a neural network. So an RL agent might use FCNN, CNN, RNN, or transformer. You wouldn't say I'm using an RL architecture, you'd say I'm using reinforcement learning to train an agent whose policy is a CNN based neural network. Okay, glad I've got that cleared up now. And I've got this cleared up as well. I guess I can close this now and probably close this as well. I think I'm going to stick with PyTorch for, um, or well, the Python side for doing, what was I saying? Yeah, I think I'm going to stick with PyTorch and the Python side for doing reinforcement learning whenever I manage to get to it, that is. Because now that I realize that, okay, reinforcement learning is less about running the model and more about training the model, it kind of seems like I might be able to accomplish a lot more using Python. Now, give me a second while I take a sip of my energy drink and hydrate, and then we are going to learn something here. Actually, there's a, you know what? We could start something. Hold on. I have an idea. Wait. Oh, also, in the meantime, I could take a piss break. So I think I'll go to BRB and come back. So give me like 2 or 3 minutes and I'll be back. Okay, so I need to end the stream here. But yeah, that's going to be it for today. I hope you guys have a nice day, and I'll see you all next time.